Okay, welcome to lesson 6, exercise 3F. We're getting towards the end now of chapter 3. We've got F, G and H to do. I want to get it all done before we break up. Okay, sigma notation. And here's my competition. I love playing board games. There's 4 of them. If you haven't played them, it's so worthwhile getting them. I think they're also mathematical. You'll love them, guys. Okay, lots of strategy involved. Okay, so sigma notation. This is the symbol for sigma notation. And if we look at what this here means, it means we are going to add up all the numbers that we get for the first 1, 2, 3, 4 terms of this sequence. So what you would get if you put r equals 1 into here, okay, you are going to get 4 minus 2 is 2, so subbing r equals 1 in here. If you put r equals 2 in here, you're going to get 8 minus 2 is 6. If you put r equals 3 in here, you're going to get 10 take away 2. If you put r equals 3 into here, you're going to get 12 take away 2, which is 10. Plus, if you put r equals 4 into here, 16 take away 2 is 14. So you would get this sequence of numbers. You can see it's an arithmetic progression. We're adding 4 between one term to the next. So the answer would be, you would just add all these up and you're going to get 20, 30, 32. That's what the answer would be. Okay, one of my games. Love it. So let's look at this one here. Have a go at this. Okay, actually I might need to explain this one to you because r in ours is a lot bigger, isn't it? Okay, so it's the same sequence, yeah? So we know this is 2, add 6, add 10, add 14, add all the way to when we get 100. So what's that? 400 take away 2 up to 382. 400, sorry, I can't add up. 400 take away 2, 398. So, how do we work out what this answer is going to be? Well, I've got my rule for the sum to n terms for an arithmetic progression. I know what that is. I know this rule here, which we did in exercise, I think it was exercise 3B. Okay, I know what A is. A is 2. I know my common difference. I'm adding 4 each time. Do I know n? Well, yeah, n, I've got 100 terms, so n is 100. So I am actually working out the sum of the first 100 terms, and I just put everything, sub in all my values. So A is 2, N is 100, and D is 4. So I just sub it all into there, and I get an answer on my calculator. So if we put all of that into my calculator, I will get 2000. Divided by 2, by the way, here. Okay, now there is another formula for the sum to n terms, which I actually missed out when I went through 3B. The other formula is this. If you're given the first term and the last term, then this is the formula for the sum to n terms. Let's just check out, so write that in your books please, you need to know that. So here I've got the first term is 2. I know my last term is 398. I know I've got 100 terms and I'm dividing by 2. And if you put all of that in, you will get the same answer. Now this formula is very useful if you don't know your common difference D. Yeah, because you don't need it in the formula. So write that down, please. Right, next. Excuse me. We're going to write this one now. We're going to go the opposite way and we're going to write this into sigma notation. So I can see I am adding up. So it's the sum of, this is when R is 1, 2, 3, 4, 5. So I'm doing the sum of R equals 1 to 5. And I want to know what is my formula going to be. What am I going to write down for my formula in here? Well, what have I got here? I've got a geometric progression. I'm timesing by 2 each time. So let's just see what my formula is going to be. I know for a geometric sequence, this is the formula for the nth term. And I've got here, A is 3, R is 2, and that would be my formula for the nth term. So that's what I'm going to put inside here. Let's just check that works. So let's put R equals 1 in. So when R is 1, I've got 3 times 2 to the 0. I've got 3. When R is 2, I've got 3 times 2. When R is 3, I've got R is 2 squared, etc. So I've got 3 plus 6 plus 12 plus the first 5 terms of this sequence. So we know this is a geometric sequence, times by 2 from one term to the next. So we use the nth term for a geometric sequence. What about this one here? Now this time I haven't got a geometric sequence, I've got an arithmetic sequence. Because I've got a common difference now of D. So I can see D is 2, A is 5. So what's the formula for the nth term? Well, that will be A plus n minus 1D. So in this case, I've got 5 plus n minus 1 times 2. If I rearrange this, I've got 5 plus 2n minus 2, or 2n plus 3. So that's the formula for the nth term. Now I want to put this series of numbers into a sigma notation. So sigma notation, I'm going to go n is 1 up to 1, 2, 3, 4, 5, 6 terms, and I'm putting it in to here. Let's just check that works. When n equals 1, I've got 2 plus 3 is 5. When n equals 2, 4 plus 3 is 7, etc. And we're adding up until we get to the last term when n is 6. 12 plus 3 is 15. So that's what I started off with. Okay, so you may have a geometric sequence or you may have an arithmetic sequence. Now, let's look at what happens with this sigma notation here. Another lovely game. Got me through lockdown at the start, that did. Okay, we want to find the sum of all of these 15 numbers for this sequence. Let's just see what we're getting. Okay, so my first term when R is 1, that will be 3 to the 0, so I'm going to get 5 times 1. My second term when R is 2, I'll have 5 times 3. My next term will be 5 times 3 squared plus my last term 5 times 3 to the power of 14. So I can see I've got a geometric sequence. It's timesing by 3 each time. So rather than adding all these up, it's going to take a long time, I'm just going to use the formula for the sum to n terms of a geometric sequence. Let's just do n first. So the sum of the n terms of a geometric sequence will be... So if you use the sum to n terms, using a is 5, the common ratio is 3, n is 15, put it all into the formula and you get this huge number here. Right, now for this next one, okay, it's very, very similar. If we look at these two here, this was the sum of all the terms 1 to 15, whereas here you're only asked for all the terms from 7 to 15. Well, I don't know a formula to do from 7 to 15. This formula will only work if it's starting at 1, the first term. But what I can do is I can say this is equal to the sum of r equals 1 to 15 of the same formula minus the sum of r equals 6. No, sorry, r equals 1 to r equals 6 of the same formula. If I take away the first 6 terms, I will get this answer. Does that make sense to everyone? Because I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 terms. Okay. This will be 1, 2, 3, 4, 5. This will be the first 6 terms. 1, 2, 3, 4, 5, 6 terms. So that's this. Okay. This is the 7th term up to the 15th term. That's what I've been asked to get. And the whole lot is the sum of all 15 terms. Now I've got my answer for here. I worked that out at the beginning. And I'm just going to take away this sum. Now, I'm not going to go through all the method for that because it's just the understanding that I want you to understand. Okay? It's this that's crucial. So if I asked you, for example, let's just make sure that completely makes sense. If I asked you to find the sum of something, whatever that is, from r equals 10 to r equals, let's say, 22, you would do r equals 1 to 22, you get the whole sequence, and you take away, and this is the same, whatever's in this box, whether it's a geometric sequence or an arithmetic sequence, r equals 1 to what value would you go here? This is the crucial. R equals 9. Yeah, 1 less than here. Okay. Right. I hope that's taken it all in. Play it back to you if not. Okay, what other questions have I got? Oh, another amazing game here. Exploding Kittens. Great for family entertainment, that one. Right, so let's evaluate this one. Now, a little bit different here. I've got all the way to infinity. Right, is this going to be a sum to infinity then, maybe? Well, let's see what I get. Let's just see what kind of sequence this is. Right, when r is 1, I've got 5 times this, plus when r is 2, plus, let's just do one more, plus when r is 3. And obviously this goes on to infinity. So what have I got here? I've got negative 2.5 plus, just going to do this on the calculator, 5 divided by 4 So that will be 1.25 and it will be positive, plus 5 divided by 8 will give me negative, because it's to an odd power, negative 0.625. So what's happening each time I'm dividing by negative a half? You can probably see that from the formula. So my r is negative a half. So I know I've got a sum to infinity, which I know what my formula is. It's this. And I know there's a sum to infinity because the modulus of r, remember this only exists if the modulus of r is less than 1. So let's work out what the sum to infinity is. Okay, because it's infinity, because we're going to infinity here. So I've got my first term, negative 2.5 divided by 1 minus a half. So if I put that into my calculator, 2.5 divided by 3 times by 2 will equal minus 5/3. So my sum to infinity in this case is negative because it's starting off with a negative value here. Okay. And obviously it's got to be less than negative 2.5, which this is. Okay, this would be negative 1 2/3, which is, we know, is less than negative 2.5. Okay, lovely jubblies. Right, last one. You're going to have a go at doing this one. Evaluate. Oh, it's just a 3 here. 3 from r equals 1 to 20. Well, all that means is I've got 3 how many times? Well, how many values have I got here? Well, I'll have 16 values. So this just means 3 lots of 16, i.e. 48. That's all that means. Okay, so your go now. I've given you all these questions to do. Another fantastic game here. Again, another favourite of mine. Okay, look forward to all your work. Have a good day.